Alright, welcome back. Today we're going to be continuing on with our discussion of logs. So we're still on section 10.6. Now we are going to be solving exponential equations. And there's a few things I wanted to discuss today. One thing I wanted to discuss is we saw a problem like this in the homework where it was the log base 2 of 5 is equal to x. Now your calculator only knows how to do log base 10, so we can't type this into the calculator. What we had to do is use the translation property and say 2 to the x is equal to 5, then take the log base 10 of both sides, because that's what your calculator knows how to do. It brings the x down using the power property, and then divide both sides by the log of 2. And we'd get x is equal to log of 5, close parentheses, divided by log of 2. And this is 2.3219. If you were to actually plug this in, so 2 to that power, I know 2 to the second is 4, 2 to the third is 5, so the number 2 should be raised to is somewhere between 2 and 3 to get 5, and the answer is 2.3219. Now, what if the problem was this? Log base 3 of 7 is equal to x. And we'd be going through the same steps. It'd be 3 to the x is equal to 7, take the log of both sides, bring the x down, and then divide both sides by the log of 3. And we'd get that x is equal to log 7 divided by log 3. This is 1.7712. But you could see we did pretty much the same exact steps as the last problem. Which brings us to something called the change of base formula. Now you don't have to use this, but it makes our lives a little bit easier. It says that whenever you have log of a base of a number, we could skip these steps right here and just jump to this step, where it's just, if you look, right, log base 2 of 5 turns into log 5 divided by log 2. Log base 3 of 7 turns into just log of 7 divided by log of 3. Anytime you have a base other than 10, if you want, you could skip these middle steps and just do the log base 10 of A divided by log base 10 of B. It works every time, and it just saves us a few steps. You could see that's pretty much what we're doing here. It's the same thing. We're just skipping those middle steps. Or you could use the translation property, and you don't have to use that formula. It's not necessary to use that formula. All right. So today what I wanted to do is just continue on with some more logs, and I wanted to introduce you to a new number. The number is e. Now you guys know we have some unique numbers in math. One of the unique numbers is pi. Pi is equal to the circumference of a circle divided by the diameter. So if you were to take a circle with a diameter and you were to divide to see how many times that diameter could be wrapped around the circle, well, it would go once. That's like one diameter right there. Here's like a second diameter. This would maybe be about 3 diameters. But then you'd have a little bit left over, and that little bit left over is 0.1415 diameters. Or in other words, you know that pi is about 3.1415. Now in math we have a number e, and e shows up sometimes, especially when we're talking about logarithms. And what e stands for is e is 1 over, it's actually written like this, e is equal to the sum from n equals 0 to infinity of 1 over n factorial. So n factorial, like 2 factorial, just means 1 times 2. 4 factorial means 1 times 2 times 3 times 4. So you could see a pattern there. What E means, this is summation notation, which you'll be learning about probably in a couple of years. What E means is 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial, and this just keeps going on for forever. 0 factorial is just 1, so 1 over 1. 1 factorial is 1. 2 factorial is 1 times 2. 3 factorial is 1 over 1 times 2 times 3, and that goes on for forever. Bottom line is what you need to know, just like you know that pi is about 3.1415, you need to know that E is about 2.718. All right, so that's one thing that I would like you to know. And we actually have a log with a base E. So you know that square root really means the second root. You know that log really means log base 10. On your calculator, by E, you could see that there's an ln button. ln button really means log base E. Ln is Latin for logarithmic natural, which it doesn't really matter. Whenever we see E, we could use ln. The reason why you want to do this is because of the inverse property. Remember we talked about the inverse property? The inverse property of logs says that if you have an exponential to a log with the same base power, these bases cancel and you just get x. Also, if you have a log with the same base of an exponential, they cancel and you just get x. So with ln, what happens is if you have the ln of e to a power, really what this means is this is log base e of e to a power, and they cancel. So anytime you have ln and e next to each other, you could just cancel them out. It's the same thing if you had e to the ln power. That's really just e to the log base e of x, and you know that they cancel out and you would just get x. So let's take a look at some problems with e, and then we'll go over a few more logs and that'll be it. So what would you do if I asked you e to what power is equal to 7? Well, the smartest thing to do would be to take the ln of both sides. You don't have to use a power property with this. You could just cancel this out because this is really just log base e of e to the x. So these just cancel. You don't even have to show that step. You could just say x is equal to, and then the natural log of 7 is equal to 1.9459. All right. So what about a problem like this? E to the x plus 1 power is equal to 5 to the 2x. Something like that. Well, we see it's an exponential equation, and we see we have a base e. Let's go ahead and take the natural log of both sides. ln and e, they're inverses, so they cancel. This one's pretty easy. And you could actually bring the 2x down using the power property. So I'm going to have to figure out what this is on my calculator. 2 times the natural log of 5. And my calculator is telling me that is 3.2189x. Subtract x on both sides. We get 1 is equal to 2.2189x. And divide both sides by 2.2189. And my calculator is telling me that that's 0.4507. All right, so maybe we'll do one more example with logs. We'll maybe just do a hard one here. How about if it's 2 to the x is equal to the square root of 3 to the x minus 2 power. Now you had a similar problem in your homework, and we said if you watch the homework review that logs and powers go well together. So let's convert this second root to a 1/2 power. Power to a power means we multiply. And then you could use ln if you want, or you could go back to using regular logs. Really, we only use ln. ln is really only necessary if you have a base e. If you don't, you could use regular log, you could use ln, you'll get exactly the same answer. See, I'm distracting myself here. We're taking the log of both sides. From here, we could bring the power down. And divide both sides by log 3, so that way we don't have to distribute a decimal on the right. We get 1/2 x minus 1, and we're going to figure out what's log 2 divided by log 3. That comes out to 0.6309x. Bring this 1/2 over. And we get 0.1309x. And we can divide both sides by the number in front of x, just like we usually do. It's a little sloppy because we have decimals, but I mean, it is what it is. We'd get x is equal to -1 divided by 0.1309, and the answer would be -7.6394. So your homework for tonight, I would like you to please do the worksheet that I have attached to this assignment. Thank you very much. Have a nice day.